Okay, so now that we have a little background in electromagnetic radiation, now we can start talking about what that looks like. So how we get our different physiological responses are going to be based on how we manipulate the wave. So how we manipulate the properties of the energy in order to get the results that we want. And so we'll call that modulating the waveforms. So when you think of the shape of the wave, and what you visualize, the shape can be altered by potentially altering one of these concepts. And so we'll talk about each of these. The amplitude or intensity, the shape of the wave itself, or what we call the wave form, the pulse duration or pulse width, sometimes called phase duration or phase width. Your book tends to focus on phase duration. Other books focus more on pulse durations, and the machines sometimes use either term, so you need to kind of understand both of those terms. The rise time and the decay time of the wave, so how long does it take to get up to its peak and how long does it take to get down. Duty cycles, so the on-off time of the wave, the frequency, or sometimes called the rate of the wave, like we said, that hertz or the pulses per second, and then the wavelength, which we already talked about. Those two things are interchanged or related to each other. So if frequency increases, wavelength has to decrease, and vice versa. So talking about the waveform itself, so the type of wave that you can have. So we have the type of wave that is formed based on the type of electricity that we have. So we have direct current, which is a unilateral flow of the electrons. So think of it like a battery, with a flashlight. You turn it on, the electrons flow, so the circuit's complete. So remember that you need to have a complete or closed circuit for the electrons to be able to flow. If you have an open circuit, meaning there's a break in it, an incomplete circuit, that's going to stop the flow. So a direct current is literally you turn on the flashlight, electrons flow, you get the energy released in the form of light. So it's a unidirectional flow. Alternating current is what our electricity that comes into our homes and our buildings and so on uses, and it flips the poles on the battery. So normally in the DC current, right, electrons come out of the negative pole, the cathode, go through the resistor, in that case the light bulb, and then comes back to the positive pole, the anode. In an alternating current, they use a transformer to turn the poles from positive to negative and to keep switching. And so you get this sine wave, or some version of an up and down wave. So the current cyclically changes. So the sine wave is the most basic form of that. And then we can get into pulsed waveforms. And so you can have a pulsed monophasic, which we see here, where there's a time. So if this is the zero line, so no electron flows, electron is flowing, electrons aren't flowing, electrons are flowing, electrons aren't flowing. And so you have this pulsed, or these polyphasic forms. And this is called monophasic because we're always above that zero line. We don't alternate like we do here, going above and below. Okay, so that's a monophasic waveform, whenever it's just one direction above or below the baseline. Can also have biphasic, which is taking this alternating current, and you can have the sine wave, that would be a biphasic, or you can have a different shaped wave. These are kind of square waves. You could have peaks, whatever you want, but basically you have, again, a part that is above and a part that is below the baseline. So these are asymmetrical ones, where one direction looks different than the other direction. You can also have unbalanced, where the average of under the wave, what we call the average intensity, don't equal out. Or you can have a really symmetrical one, which would also be what the sine wave would look like, where it's exactly the same top and bottom. So those polyphasics are most likely what we will end up kind of dealing with in our modalities. So again, they can be either monophasic or biphasic, where we have kind of this off time that the electrons aren't flowing. So it's a series of pulses, usually of short duration. We're talking, we wouldn't even be able to recognize it, because we'll also have something that we call a duty cycle, which is us actually turning off the current. So this is just pulsing within the wave. We can actually turn off the current and turn it on with our duty cycle. But it's a series of pulses of short duration followed by a short period of time where the current's not flowing. So we'll talk about high volt pulsed stimulation, or HVPS. That's a form of this. Our typical biphasic forms, which are what's going to be used for our TENS and our neuromuscular electrical stimulation, are going to be polyphasic forms. Okay, so our first term, we have amplitude or intensity. These two are used interchangeably a lot of times. And it's the intensity of the current. So when we look at the wave itself, it's going to be, again, kind of talking about the peak that wave gets to. So the higher the amplitude, okay, or the higher the intensity, the greater the depth of penetration we get, and the greater number of fibers that we can stimulate. And so you can talk about peak intensity, which is just what level does that wave get to, or you can talk average intensity, which is the average, so the area under the wave or under the curve. So in the case of a perfect biphasic, those actually cancel each other out, and we have an average intensity actually of 0. But the average intensity in this case would be a positive number. If we're just talking peak intensities, then we get to talk about just whatever this number is here. So most of the times we're going to be talking about peak intensity. So if we look at our waves, again, this is a biphasic, this is a monophasic. When we talk about our amplitude, we're talking about F over here, so our intensity. So how tall are these waves? And so this is something we're going to be able to adjust. This is actually going to be a lot of the sensation that the individual feels will be controlled by intensity. So when you've seen people set someone up to stim and they've turned up and say, you know, tell me when you feel it, they're turning up the intensity or the amplitude of the wave. So it'd be F over here, it would be the height right here on the monophasic. So other things that we'll get to control within the pulse, okay? One is what we call pulse duration, or you'll hear talked about phase duration as well. Pulse duration is the time it takes to complete one cycle. So in the biphasics, that's the duration of the two, what we call phases. So the up part and the down part. Monophasic, since we only have one phase, okay, mono meaning one phase, then the pulse duration and the phase duration are equal, okay, if we're talking monophasic. If we're talking biphasic waveforms, then usually, and if they're symmetrical, like our sine waves or some of the other symmetrical ones that we do, then the phase duration is going to be half of the pulse duration. Duration is really important because as we start talking about, again, manipulating these waves to get certain energy, at any given intensity, the pulse duration will directly affect the physiological response. So if we lengthen or shorten that pulse duration, we're going to get a different response, potentially even a different nerve that we can target. So when we talk about our pulse durations, in a biphasic waveform, pulse duration is C. So it's phase 1, phase 2. That's the length, sometimes also called pulse width, but we'll use duration more so. Phase duration in a biphasic is just one part of the phase. So from 0 to 0, or from 0 to 0. So that is our phase duration. In a monophasic, pulse, and you can't really see my E here, pulse and phase duration are equal.